Snapshots. So snapshots are simple operations as well, and you can remove a snapshot between others very quickly. So if you're new to storage and you're unsure what a snapshot is, I'll give you first kind of the official definition, which is a point-in-time copy of a set of data, which probably tells you nothing. What it really is it's a list of changes. So if I have a volume and I want to snapshot it today before I apply a patch to Windows, the storage array will start keeping a list of changes. As I make changes to the original volume and do the patches, the array keeps a list of things that have changed, so it knows how to change them back if I want to. A lot of arrays, including Extreme.io, will let you mount those snapshots as another volume. So you could mount what your server looked like before you did a patch on another system. You can also, if there's a problem with the patch, roll it back to the snapshot and your server will go back to as it was, or the data in the application, I guess, on the volume will go back to as it was before the patch. You can also do snaps of snaps. So I have original data, I take a snapshot, take a snap of that, take a snap of that. Common in test and development environments where we have sets of data and we're applying changes or code updates and we want to do snaps of snaps. And the beauty of snapshots is I could just clone the original data and give somebody a full clone, but that takes twice the amount of space. If I had 3 snaps, I'd be at 4 times the amount of space. So what we do here is snapshots are, again, simple metadata updates. You take a snap, the content engine within Extreme.io says, I already got all this data, I'm just going to add pointers. And then if I snap that, it adds another set of pointers. But you can also delete a snap in the middle and it'll merge these snaps together. Some arrays, as you delete a middle snap, will also delete all the snaps off of it. They're not intelligent enough to merge those changes back, but Extreme.io is, and it makes for very quick and easy snapshot operations. So that's it for how this thing works. First, how does it handle incoming data? Well, as we just heard, basically data comes in, broken up into 4K chunks, run through a SHA-1 hash. It's checked against the metadata table to see if it's unique. If it is not unique and we've seen the hash before, we just add a pointer in the metadata table, and that's how we dedupe the data. If it is unique, we've never seen it before, we had a new entry to the metadata table, and we write that 4K out to a free stripe somewhere on an SSD in the cluster based on what the content engine tells us. So the content engine is where the magic happens. It's how we get easy metadata updates with things like snapshots, VAI, and deduplication. And it uses that hashing algorithm as kind of a random number generator to distribute data all across our cluster, across however many bricks you have and however many SSDs you have. Very cool, very elegant, very efficient. I/O data path. We saw that any cluster, or I guess any brick and any controller in a brick, has access to any data within the cluster. So hosts aren't redirected. All controllers are active, so you can request data from any volume, any LUN, from any other brick through any controller that you want to. And it's efficient storage of data. Everything is done in 4K blocks. We do thin provisioning by default, and there's no fragmentation or reclamation penalty. Full VAI support integrates with VMware very nicely. Very fast clones and copies thanks to the metadata operations. XDP allows us to do fast rebuilds, up to 5 disk failures per brick. So if you had 4 bricks, you could actually lose up to 20 drives total, which is crazy, and not have a performance hit. And it is, again, N+2, but check your code release to see if you can have 2 simultaneous failures. Else you've got to wait to that first drive repairs in like 15 minutes before hopefully you lose a second one. And again, snapshots. You see the magic or the beauty of this content engine. Snapshots are very simple, allows them to be merged if you delete one in the middle, but everything is quick and it's done in memory. So that's it for this lesson. As we move on to the next, we're going to start talking about how we actually implement this, starting with physical requirements, rack space, power, what you need to know to get ready, things like that.